want to welcome you on my YouTube channel. Today we are going to discuss something about classical square opposition, which is a very good topic of logical reasoning in UGC NET paper 1, which is teaching and research aptitude. Here we will see classical square opposition. What do we understand by classical square opposition? Classical square opposition means there are some propositions. Propositions means statements. There are some statements they have truth value the true, either true or false. They cannot be both. So here are a proposition is one of the example of a proposition where all apples are balls. Example of E proposition is no apples are balls. I example some apples are balls. O example some apples are not balls. Here we have to see this is all, this is no, this is some not. Okay, from all this is A E I O. This is actually done. We have to remember this square. This is the square of opposition. This is A E I O. There are some relations between A and E. The relation between A and E is called contrary. The relation between I and O proposition is subcontrary. The relation between A and I is subalternation, and the relationship between E and O is subalternation, and the relations between A and O is contradictory, and relation between I and E or E and I is contradictory. Okay, our truth value or downstreams and false value upstreams. From here we need to remember another thing also. A E which is near letter, true or false. A E true letter, next letter is false, which is near letter. Okay, so A and E, at least one of them is false. When A is false, E can be true or false. When E is false, A can be true or false. If it is given that either of them is true, then one of them must be false. If A is true, then E is false. If E is true, then A is false. And from here we see that IoT. We know Internet of Things. IoT. It means at least one of them is true. Yes, at least one of them is true. When I is false, O will be true. When O is false, I will be true. Or if I is true, then O can either be false or true. If O is true, I can either be false or true. From here we remember IoT, at least one of them is true, and from AEF, at least one of them is false. Okay, falsity goes up and truth value goes down. And this box is also, we need to remember, this is A, E, I and O. Alright, A, E and I, O. You can see that T, 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 diagonally T, 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 and diagonally F, 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 and at the end we put D, D, T. We remember DDT. Generally we know DDT. DD will now go up. Now they are going up diagonally upward. Diagonally upward. DD. Then we fill up all the box. This box will be filled F. This box will be F. F. How we are going to make this? Here you see. This is the box. A, E, I and O. Now we are going to make the box in this way. This is T, 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 diagonally F, 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 F. At the lower DT, D will go up, D will go up, and this will be filled with T, F, T, F. So T, F, T, F T. Okay, alternative T F T F. This is in this way we will fill our square proposition. However, T refers to true and F refers to false. D is undetermined. Okay, first of all we need to remember all these things. Okay, take a snapshot from here, and thank you.